All right. Hello, Get Better Faster Nation. I am Dr. Jason Bradley, and along with my co-host, the one and the only James Chester, and our incredible executive producer, Rachel Bradley. By the way, it's our anniversary today, so happy anniversary, my love. We want to welcome you to another exciting episode of the Get Better Faster podcast. Today, we're joined by a true pioneer in microbiome science, someone who spent over 20 years revolutionizing how we understand gut health and its connection to virtually every aspect of our well-being. Kiran Krishnan is a research biologist who co-founded Microbiome Labs, the leading microbiome therapeutics brand trusted by healthcare professionals worldwide. He's conducted groundbreaking research, published in scientific journals, holds global patents, and has helped launch multiple companies, all focused on one mission: making wellness accessible through the power of the microbiome. If you've been struggling with autoimmune conditions, digestive issues, brain fog, or chronic inflammation, and you're sick and tired of Band-Aid solutions, this conversation is going to change everything you thought you knew about healing from the inside out. Without further ado, Kiran, my friend, welcome to the show.
Thank you so much for having me. It's such a pleasure to be here.
Yeah, it's always dynamite hearing these introductions that Dr. Jason drafts up, because I believe it gives people a real strategic advantage that listens to our show to say, wow, I want to stick around and hear what this guy's going to talk about. So, Kiran, welcome. Without any further, you've been in the research world for 20 years, yeah?
Yeah.
And when did you first realize that the gut microbiome was the missing link most doctors were ignoring? And what was your aha moment that, darn, this is what I believe will get people better faster?
Yeah, actually, that's a great question, because there were some significant aha moments for me. I went to the University of Iowa, and I was in the Department of Microbiology and Medical Science there, which is part of their School of Medicine. And one of the labs I was working in, and outside of studying, I also worked and did research in a number of labs. One of the biochemistry labs that I was working in was actually part of the Human Genome Project. They were one of the many labs throughout the country that were working on certain part of the human genome. And so I had a really interesting inside track on what's going on with this sequencing of the human genome, right? So these are our genes in our chromosomes. And the funny thing that I remember was that the estimate was that humans would have a minimum of 250,000 genes, because we are so complicated, right? At that point, the Drosophila, the fruit fly's genome had been sequenced and all of that. And so they had a few thousand genes, 8 or 10,000 genes. And then some worms were also sequenced that had 15, 20,000 genes. And so the estimation was, being as complicated as we are, we should have over 250,000 or more genes. As it turns out, at the end of that project, we discovered that humans have around 22,000 functional genes, right? Which is crazy when you think that an earthworm has 30,000 functional genes. A cockroach has 21 or 22,000 functional genes. So that left a massive gap. And I remember this being an issue when I was in those labs and working in the research in that space, going, how the hell do we explain this, right? How is it that we are wholly inadequate in our genome for all of the things that we know we need to conduct to be sophisticated humans? And that's when there was this question of, maybe there's microbes in our system that carry more genetics for us. And then a few years after that, the Human Microbiome Project kicked off, that aimed to study the ecosystem within us. And what we came to find out was that we have over 2.5 million microbial genes in our system, right? 21,000, 22,000 human genes, 2.5 million microbial genes. And we use a good portion of their genetics to conduct functions. We've also outsourced a lot of critical functions to these microbes, because genetically we cannot do them. So that was a bit of an aha moment that, oh my God, if so much of our functionality is coded for by microbes or conducted by microbes, then clearly microbes play a significant role in our overall health and our overall outcomes. So understanding our ecosystem and the microbial world within us could be the most important thing that we come to understand about the human form, right? So that realization happened over a few-year period. And once that kind of clicked in my head, I jumped in and said, okay, this is the tip of the spear that I want to be involved in the world of the microbiome.
Kiran, that's a fact. I got to repeat what you said. If I heard correctly, an earthworm has a more complex genetic makeup than humans. and we're basically similar to cockroaches.
Exactly.
And it's interesting because when you talk about functional genomics, our genes controlling and regulating, so much that goes on. What I'm hearing is that our genome sequence is actually not designed to as a standalone, that we are basically having what I'm going to call, and maybe I'm misinterpreting it, but a symbiotic relationship with these microbes in our gut. And throughout our body on the microbiome for the system. That's an amazing thing. I will say, also props to University of Iowa. That's my alma mater as well.
Awesome.
I could go on and on about that, but it's interesting. In all of my medical training, I've got 3 doctorate degrees and another master's degree and a whole bunch of certifications and all that shit. No one said this. No one in any of my didactic training said, by the way, we need those microbes because of their genetics, right?
Yeah.
So what do you think the missing gap is with medical training? Why isn't this being taught in the medical schools?
I think a lot of it is because, automatically what tends to happen in allopathic medicine for sure, and in medical science is we end up siloing the body. Right. And the thing about the microbiome is that it's a systems biology approach. Right. So when we start to really understand the microbiome, we start to see all the axes between the gut and all these other regions of the body. Right. We've everyone heard about the gut brain axis, the gut skin axis, the gut lung axis, all of these axes. What that indicates is that all of these systems are interconnected in a very intimate way more than just circulation and soft tissue holding it all together, right? And inevitably in medicine, we end up siloing the body into compartments, and people get very deep into the compartment, which then negates a system-based approach view. And so because that is the inevitable way in which the physiology and medicine is taught, we end up omitting so much of the important bigger picture. Because it's all about, let's dive into, okay, you're going to specialize in the heart. You're a cardiologist. You're going to learn everything about the heart. And not only that, there's about 7 different types of cardiologists, right? There's interventional cardiologists, there's intensivists, there's, people that only do surgeries, there's so many specializations on each given organ system. I think that practice, and maybe that needs to happen, obviously, because there's so much complexity in each of these organ systems, I think, but that aim to get to that specificity on that one part of that one organ system negates the whole systems view as being important, right?
I see that, from a functional medicine point of view or precision medicine or whatever the new word is that we're using. I always say that we have to be all of the ologists for all the ologies because it is a systems-based approach. So, it's lifelong learning for people that want to get to root causes. I also just want to share, and then I'll pass it over to James. My old joke is, specialists and experts know more and more about less and less until they know everything about nothing. And I think it really is, the cardiologist and the endocrinologist and the gastroenterologist and the neurologist, like nobody's talking to each other. And even if they are, it's in medical notes and they're not collaborating. And I don't know that the general public is aware of that. So sometimes when I chat with people and they're like, well, I saw the fill in the blankologist, I'm like, I already know I already know where it's going. I can predict on, some prefab fill in the blank, put you in a box, prescribe, what it's going to be. And it's just really interesting to hear this from a microbiologist point of view. James, I want to throw that right over to you.
Yeah. As you guys were talking, it got me really curious. And I think that that's the greatest part about this show that Jason and I run here at Get Better Faster, is it's brimming with curiosity. And we get subject matter experts like yourself, Kiran, that are on here. I couldn't help but think about a couple things. Number one, terrain theory. And when it comes to the health of soil. And if you strip all the nutrients out of soil, what does it do to the quality of the life that it grows? It's deficient. And I think a lot about, when people tell you that, the first gut's not the brain, or the brain's not in the gut, it's not in the brain, it's not in the head, it's in the gut. And I'm like, okay, well, that makes a lot of sense. But what if we're not populating it with the right things? And then I'm like, well, if you want to populate the gut with the right things to where it makes the first brain smarter, which is in the gut, to make the top brain smarter, which is in the noggin, and it connects it all together. And we're not compartmentalizing this, like you're saying, is we bring the whole body together, whole being health, and we start to think about it. And it's not in chart notes. It's actually the person in front of you. They are their own chart. And the only way to actually get to the point of this is say, what are you feeding yourself? And how healthy is your gut microbiome determines on your quality of life, I believe, and how you represent in your life. And if you look at like, what are you feeding it? Some people think that you get probiotics from yogurt. Some people think that if you take a shot of apple cider vinegar, that's going to give you like your zest for life. But as you've been doing this, how did you discover like the methods that you use and help to like make people understand that it's a full body care package and it's not some I'm a specialist within the specialist in the specialist, like Jason says. Eventually you won't know anything, but it seems like you figured out some things with how you feed the body in order to get the outcomes you're looking for.
Yeah, and in fact, you mentioned a very important word, terrain. Terrain is critical, and in fact, I'm currently teaching a certificate course for practitioners on terrain theory for the microbiome. How do you reframe the view of the microbiome from a terrain perspective? And that's a really, really important and interesting area to me, because the terrain changes the functionality of the players within the terrain, right? And there's tons of examples of that. I'll just give you one example, right? So if you look at osteoarthritis, which is a degenerative joint disease, right? So you're losing cartilage over time. Osteoarthritis, according to the WHO, is the #2 cause of disability worldwide, right, which is massive. By a number of estimates in the US currently, there are roughly 50 million Americans, adult Americans over the age of 18 that have osteoarthritis, right? So it's a massive issue, and they're all, a big percentage of them are going to end up being disabled down the road. So then what would people normally do? They would go to a joint specialist, a rheumatologist or someone like that, right? They're going to look at the joint and go, you've got a significant amount of degradation. They might do an MRI, an X-ray. They'll look at the soft tissue in the joint, the cartilage. It's degenerated to a certain level. At that point, the solution is pain management, right? So with lots of pain drugs, so to help you be comfortable. And then at some point, maybe surgery, maybe replace the joint with a bionic joint, right? There is zero view on why that is happening, right? Why is that joint being degenerative? And so then you look at the terrain and you go, there's very clear mechanisms in place. So you take, for example, the cells that make cartilage, right? They're called chondrocytes. These cells, their whole job is to lay down cartilage. They take collagen, they lay down collagen, and they repair and they rebuild cartilage for you your whole life. These same cartilage building cells, which are anabolic cells, right, which is the building process, in the terrain of high inflammation, especially interleukin-6, TNF-alpha, and IL-1. These are quintessential pro-inflammatory cytokines. When those pro-inflammatory messengers are up, this anabolic cell that builds cartilage not only stops building cartilage, it actually reverts to cartilage degradation. It actually releases enzymes that eats away at your cartilage, right? So here is a building cell that repairs stuff for you and builds stuff for you all day long, most of your life. When the terrain shifts and inflammation hits to a certain level, the job of that cell changes, and now it's a degradative cell, right? And that happens throughout the body. That happens in your muscle cells, in your brain cells, in your neurological cells, in the lining of your gut. All of these cells switch from being reparative, building, to degradative based on the terrain, right?
I'm going to jump in for a quick minute. Then I'm going to pass it to Dr. Jason. I'm going to make a poignant statement. What happens when you put sugar in a gas tank on your car?
Well, it's a good way to ruin your engine, right?
Yeah. What happens when you put sugar too frequently into a human's body?
Yeah. Same thing.
A good way to ruin a human body.
Yeah.
Yeah,
Absolutely.
absolutely, James. Thanks for that analogy too. And I just want to just come back and just get clarity again, and then I have a question. When we're talking about these building or anabolic type of cells, um, and it's related to the terrain, when we have, if I'm understanding correctly, when the terrain is not the way it's supposed to be. So again, maybe we have, I'm going to use words here, but it could be pathogens of any sort,
Mhm.
could be overgrowth of commensal bacteria, not enough of what we call probiotic bacteria. When that terrain is off, we're switching from building and repair to either neutral at best or even destructive and degradative. Am I understanding that correctly?
That's exactly right. So let's connect then what's happening in the gut to what's happening
Yeah.
in the joint, right? So again, osteoarthritis is a very, very prevalent degenerative condition. It's the #2 cause of disability worldwide. That is a massive, massive problem. It's also one of the biggest uses of NSAIDs and other pain medication. So we've got this massive health crisis, and then how are we managing it? We're looking at it just at the joint itself and going, aha, things are breaking down. I'm going to give you pain medication and maybe anti-inflammatories, and at some point replace the knee. But when you look at the terrain perspective, here's what you actually see. Most of those people with osteoarthritis have very dysfunctional gut microbiomes. They have dysbiosis in the gut microbiome, meaning imbalance of good and bad bacteria. One of the key results of having that imbalance is the gut becomes leaky, right? So the barrier system in the lining of the gut becomes degenerative as well. And so toxins like endotoxins that are made in the gut leak through on a regular basis and end up in circulation. The result of that leakiness of endotoxins is a significant elevation of these pro-inflammatory cytokines called IL-6, IL-1, and TNF alpha, right? And when those go up, that accumulates in the joint space and other areas of physical stress. Now, the joint space is an area of physical stress because it's weight bearing, it's load bearing, right? And so blood is often trying to get there to try to repair things, but this blood is inflammatory. It's getting there, it's pooling in that area, and it's switching the chondrocytes, the building cells, into degradative cells, right? So what's actually happening with those individuals is it starts with their gut, and their entire terrain is in a pro-inflammatory catabolic mode, right? And the beauty of it is you can reverse all of that. You can actually get to a point where you're rebuilding cartilage. We have 3 randomized control trials published in almost 2,000 subjects with osteoarthritis, showing even people with bone on bone that if we switch what the terrain looks like, we can turn on those cells back to rebuilding and rebuild cartilage and get them walking again, completely off pain medication, and then dramatically lowering the risk of disability, right? All by switching the terrain. But you'll never see that if you just focus in on the joint.
Yeah, and I think there's so much to unpack there, man. And I appreciate you just teeing things up for me. First of all, I just want to speak from experience, and then I want to share an anecdote, and then I have a question. I know, so I have some inflammatory joint conditions. Some of those are autoimmune driven, and I know that when I don't take care of my gut, so that's going to be my diet. Taking my my targeted probiotics. I have more pain. I mean, I can speak from experience. And sometimes it's all, I don't want to say debilitating because I have yet to have debilitating pain. I'll push through it. That's not a challenge to the universe, but I refuse to be put down by pain. But I get it. I get that pain and I get taking care of it. The other thing is, so I want to speak from experience. The anecdote, I was just on a call earlier. I have a group call with my clients every Tuesday morning. And I was on a call earlier with a client of mine named Jan. And she said, Dr. Bradley, I switched my diet, like you said, and I, took my probiotics, and she has, pretty profound rheumatoid arthritis. And she goes, look, I can move my hands. I can take my ring off. They're not swollen. She's like, this. And I'm like, Jan, it's a win, but really we didn't give her any pain medication. She's not taking anything for pain.
Right.
She's literally just, feeding her gut the right foods. So I want to talk about that. That's the first question. And then the second thing is she's re-inoculating. I don't know if that's the right word to use, but her gut with the right probiotics. So I love that you shared that, because that's not just osteoarthritis, that's a rheumatoid arthritis and an autoimmunity. So a couple of questions kind of related to that. Number one, there's this ongoing, I don't even know if it's a controversy, but do you do prebiotics? Don't you do prebiotics? What the heck are prebiotics? First of all, should we be doing them? Shouldn't we? Is it one size fits all? Are there targeted foods that we should be eating to help grow that healthy microbiome in the gut? There's that question. And then second of all, do you think that I'll hold my second question. Yeah. So are there targeted foods that can help restore the healthy microbiome gut population?
Yeah. So there are, I would say, so when we're thinking about gut health, there are 4 or 5 staples that people should consider, and find the right versions of it for you. But I'll talk about what I recommend of these 4 or 5 staples, right? So the 4 or 5 staples will be probiotics, prebiotics, fiber, polyphenols, and then the last part of it, which can be counterintuitive, is potentially fasting as well. Right. So then let's break those down a little bit. A probiotic, we developed the spore-based probiotic. So we had the privilege of pioneering that in our space, in the community, in the wellness and functional medicine space. And then now it's also growing in the allopathic space. But what made that a really effective probiotic is the ability of those strains to modulate the rest of the microbiome, right? Because it doesn't matter if you put in 50 billion, 100 billion, 200 billion, it sounds like a lot, but you're putting it into a sea of 30, 40 trillion organisms, right? Which is a massive ocean of microbes. Even 50 billion probiotics is like a drop in the ocean. So unless those bacteria that you're putting in as probiotics have some capability of modulating the other sea of microbes, they're not really going to create any profound differences. And in order to figure out what we can utilize to actually create that kind of change within the microbiome, we just went right to nature, right? We said, okay, what type of microbes do humans naturally interact with for most of their life? And it became clear that naturally, after the birthing process, after breastfeeding and getting microbes that way, after passing through the vaginal canal and getting microbes that way, the rest of your life, humans are encountering microbes in the environment, right? So these are our ancestors who were hunter-gatherer foragers. They're eating off the land. They're getting dirt in their food and their system. They're drinking waters out of rivers and streams, all unfiltered, right? So they're getting a huge exposure to microbes from the environment. Now, the vast majority of microbes in the environment are not going to function as probiotics because they're just going to die in your stomach. And then they're going to go through as microbial debris, if you will. But we honed in on microbes that had the capability of surviving through the gastric system that could come in through food. And those end up being the Bacillus endospores. And so we started studying them, and we found that they also do something interesting called quorum sensing. Quorum sensing is this ability of microbes to read other microbial signatures. So these bacteria can go into your system. It can survive through the gastric system. It can survive through bile salts and pancreatic enzymes, get to the intestines alive. And when they get there, they can study the microbial environment. And the moment they identify dysfunctional microbes, they can sit next to them and produce compounds to kill them down. They also produce compounds to increase the growth of beneficial bacteria. So we were seeing that these microbes are kind of acting like the gut police. Right? They're going in there, they're identifying dysfunction, they're identifying areas that need correcting, and they're actually physically improving those. We can see that on tests. And we've published that in papers. So that became the most effective type of probiotic to go after. Now, prebiotics can be specialized food to grow specific categories of bacteria. So oligosaccharides are fantastic prebiotics. So xylo-oligosaccharide, galacto-oligosaccharides, fructo-oligosaccharides. These are highly specialized fibers that are very complex carbohydrate structures that humans cannot digest, and the majority of microbes in your gut cannot break down because their structures are so complex. But there are certain keystone microbes, which are really important commensals, that have the capability of breaking those down. So these prebiotics will specifically feed those groups of microbes, right? Which is great. So it's targeted nutrition for some of the most important categories of bacteria within your gut. The third one, fiber. Fiber is absolutely fascinating, right? So if I were to tell you that I discovered a compound that if you took the right dose of this compound every single day, it would reduce your risk of all-cause mortality, that's dying from any disease and condition, by 45 to 50%, right? Your first thought may be, that is an amazing claim, right? Something that can reduce my risk of dying almost in half by almost anything, all-cause mortality. And I think one of the questions may be, well, that is a massive claim that should require massive evidence to prove. And I say, well, okay, there is evidence. There's about 190 published papers. There's over 153 million person years in all of those studies. One of the largest data sets of any study set there is. And those studies show that if you take this compound in adequate amounts, you can cut down your risk of mortality by almost 45%, wow. Right? Then you'd be like, oh, what the hell is this thing, this miracle thing that you found? Well, it's fiber, right? Every 10 grams of fiber you take reduces your all-cause mortality by 10%, up to 40, 45 grams, right? After that point, it starts to flatten out the mortality curve. So getting 40, 45 grams a day of fiber in your system has a massive impact.
Wow.
And the last thing, the polyphenols. Polyphenols are parts of the colored fruits and vegetables. The polyphenols act as prebiotics as well, and they feed certain categories of microbes and then are converted into really important nutrients that we need, like urolithins. Right? Urolithins are important for these engines in our cells called the mitochondria. James, you mentioned about what happens to our body when we put in sugar. Well, one of the things that happens is we choke out the engines in our cells, the mitochondria. And so when the mitochondria aren't functioning, the cells die, and then the organ that the cells make up die. One of the most important ways for us to turn on those engines and repair them is urolithins, these compounds. But we don't make urolithins, nor can we get it from our diet. They're made for us by bacteria from digesting polyphenols. And the last one, fasting. If you go through any period of fasting, 12, 13, 14 hours in a daily period, it actually increases the diversity of your microbiome, because there are certain sets of microbes that do better when you're not feeding constantly, right? So Joe, that's a 5 kind of pointed star way of thinking about things that could be really beneficial for your microbes.
That's amazing. First of all, I mean, and what a simple trick. I mean, we want people to get better faster and also expand the lifespan, but also the health span, right? I mean, this day and age, we can keep anybody alive with, different machines and wires and stuff like that for a really long time, but it's not really good quality of life. So expanding that health span is important. And something is, people are like, oh, it's real expensive to do this. And it's like, well, just eat fiber, just eat a rainbow, eat some colorful, fruits and vegetables, right? I think that's an important take home from what we just said. Is it okay if I mention a couple products by Microbiome?
Yeah, I would love that. Sure.
So you mentioned, the spore bacteria, and I want to understand, because I have used Megaspore Biotic personally and also Restore Flora. Both have, I believe, spore bacteria built into those products. And my understanding, I think Restore Flora also has some Saccharomyces boulardii, which is a beneficial, what would you call it? Beneficial yeast, right? Okay, thank you. A beneficial yeast. That said, I have seen miraculous turnarounds with when people, have to go like, what's the quick down and dirty that I can do? I'm like, change your diet, eat real foods, get some fiber, get some colorful foods, and add in spore biotics. People ask me what the difference is, and I'm going to tell you, I'm a novice at this, and I've learned a lot of what I know, from you and in your work. But I think spore biotics, we were talking about the gut and specifically the acid in the stomach, and they can bypass the acid in the stomach. They survive, if I'm understanding, they survive past the pancreas and the pancreatic enzymatic release, the bile acids, bile salts, and they literally, I don't know if I'm saying this right, but come to fruition past all of that. So they can bypass all of that. Am I understanding that correctly?
Yeah, you're absolutely right. I mean, that's one of the massive advantages of the spore-based probiotics, is that they naturally encapsulate themselves with we call it an endospore, which is a protein calcified hardened coat that protects them from things like stomach acid and bile salts and pancreatic enzymes that normally kill most other bacteria. And so they have a natural capability of surviving this gauntlet that the human body has set up to kill and filter out most microbes. So they survive through that. They get to the intestines, and when they get to the intestines, they have receptors sticking out of the spore coat that shows that they can do a molecular handshake, if you will. They can bind to receptors on the lining of the gut, which tells them that they're back in the gut, and then they can come out of this spore coat as a result of that and becoming a live functioning cell. Now, in the world of microbiology, a functioning cell is called a vegetative cell, which is counterintuitive because when we think of someone who's vegetative, they're obviously not functioning well. But a spore the spore state is a non-metabolically functioning state, and then the vegetative state is a functioning state. Now, here's the really interesting thing. Your audience may nerd out on this a little bit. So spores, one of the things that really fascinated me about them is that they've been here for way longer than humans have, right? So there are glacial ice core studies where they've pulled out samples of the environment from several million years ago, 3, 4, 5 million years ago, and they found that they can identify the presence of Bacillus endospores in those core samples, and then they can pull them out and melt them out and still grow them on a petri dish. They're still alive. Some of the oldest spores they found are tens of millions of years old that were found inside caves and salt crystals and things, and they can still plate them. They're still alive. And so they've been here a very long time, and they're incredibly robust, and we've been consuming them inadvertently throughout the course of human development.
First of all, that's amazing. And if I just want to go back to these spore bacteria, and maybe I'm wrong about this. Thank you for confirming everything that I've been thinking so far. And maybe I'm wrong about this, but spore bacteria really, like James was saying earlier, and we mentioned earlier, they're found in soil. They're kind of like, I don't mean to say that, but they're kind of soil bacteria, and they're in the soil and in the water and these things. Am I correct on that?
Yeah, they're ubiquitous in the environment. There's a little bit of a nuance to it though. So certain spores are actually human commensals, meaning they're natural places in the gut. But what's interesting about them is that they use the environment as a vector to get from host to host.
Oh,
right. So they're in a spore form when we find them in the environment. We swallow them. They stay in the spore form until they get to a part of the small intestine where they come out of the spore form. And then they go to work for us as a functional probiotic bacteria. Now, as they pass through the digestive tract, because they don't stay forever, they pass through the digestive tract. They get towards the end of the digestive tract, they go back in the spore form when they're about to be defecated out. So then that way they're found in the spore form in the environment.
Again, the symbiotic relationship there is it's astounding to me. Yeah. The more I learn about science, the more I believe there had to be a grand creator of all of this, because it's too interconnected to be random. I think anyway. That said, coming off of what you just said, there's this idea that we've become too hygienic and too clean as society. We're sanitizing everything, we're irradiating everything, we're using hand sanitizer everywhere. And I don't want to necessarily say don't do that, because I don't want germs to be spread around. But at the same time, what are we doing to our microbiome with this ultra hygienic, ultra irradiated, ultra sanitized, homogenized, pasteurized? Like, what are we doing to our gut with the gut microbes?
Yeah. So there's a couple of very clear things that we're doing that have a profound effect on how we function. Number one, it's clear that the hygiene hypothesis, which is the over-sterilization and the lack of exposure to microbes, is definitely reducing the diversity within our microbiome. And as a result of that, our immune system is actually getting quite confused, right? So the immune system is the analogy I always give. Think of the immune system as a military that has all the equipment. It has all the tanks and bombs and guns and all that, but it has no general, right? It has no one to tell it who the enemy is and who the friend or foe is, right? And as a result, the immune system actually highly depends on the microbiome to teach it what to attack and what not to attack, right? And if the microbiome is not present at the right diversity, the immune system goes haywire. So one of the things that we've seen as a consequence of this over-sterilization and lack of exposure to microbes is that our immune systems are getting dysfunctional, and thereby we are dramatically increasing the rate of allergies, asthma, food sensitivities, and all of that as well.
Go ahead, James.
Yeah, as you guys have been riffing on the microbiome and causation for representation and what's going on inside of a person's body and why what you feed it gives a direct correlation to its performance. The part we're not talking about, though, is attitudinal and behavioral and the way that it affects our the way we think and the way we behave. And I think that that's the next part of the evolution of our conversation today is if you look outside and you see brown grass, you say, oh, we water it, and then we cut it, and then we do away with the debris. And it's the same way with our microbiome, I believe, is if it's not producing and it's not healthy, we start watering it, and then it starts growing and going back to what it's supposed to do, and then we slough it off, or it goes back into, like you said, the spore form before digestion, and now you have a healthy balance of immune system. And brown grass, death; green grass, life. And I think the same way about the way that people feed themselves. And then it depends on how their attitude shows up with how their body's performing. So how would you say that there's the link between gut health and people's self-esteem and motivation and quality of life with their attitude?
Yeah, actually, there's very, very close ties to that, and I'm glad you brought that up, James. The gut-brain axis, which is the connection between the gut and the brain, and you had put it before as the first and second brain, right? And there's a few different ways to look at that. So the gut and the brain are intimately connected through the vagus nerve, through circulation, and a number of like 3 or 4 different ways. The vagus nerve is a information superhighway, if you will, between the gut and the brain. It's a neurological system. What's interesting about it, though, even though it's a bidirectional highway, about 80% of the messages on the highway are going from the gut to the brain, and only about 20% down from the brain to the gut, which means that the brain in your head is counting on a lot of input and information from the gut about what's happening in the body, right? And what environment is the host in, which is us. And so as a result of that, there's not only the messages that are going through to the brain, but then the brain in your head responds to your environment based on the signals from the gut. Now, let's talk about some of the signals that actually impact mood and outcome and so on. So a couple of the neurotransmitters that are really important: dopamine, right? We know dopamine is really important to trigger the reward centers of the brain. Someone's ability to focus and pay attention and be excited about something, get a reward-like sensation from work that's done. That is a dopamine-related functionality. And when people are really low on dopamine, or they're constantly triggering dopamine, they end up with being depressed or having addictive personalities, right? Addiction is a dopamine issue, whether it's food or video games or sex or whatever it may be, people, or alcohol or drugs. All of those things work as addictive substances because they trigger dopamine response, right? And we get addicted to that feeling because that's what makes you feel alive. Dopamine is so important for that. Now, your gut microbiome makes about half of the dopamine in your body. And then the binding of the dopamine to receptors in the brain is determined by how leaky or unleaky your gut is. When your gut is very leaky, it negates dopamine binding, right? And the same goes true for serotonin, the happy hormone, as well.
Well, I just have to finish this track with you. Now, say somebody that comes ill and they get sick, and their body's not fighting off the invaders, and some people call it autoimmunity, some people call it a head cold, some people call it diabetes, some people call it Hashimoto's, some people call it heart disease. whatever it represents as. And then they say, okay, try this antibiotic. We're talking about
Oh
the
my.
gut biome. Now, say we introduce this thing into the body to help it, or like you said earlier, an NSAID for inflammation. We put this foreign invader inside the body. It's like throwing Roundup on the seeds in the field, or it's like spraying a herbicide to kill the bugs for the food, and then we eat it. So I guess the pathway I'm going here is, how do you recover from like a scorched field inside of the gut biome when somebody ingests an antibiotic, or they get a radiation therapy, or they start taking anti-inflammatory medicine that's really, I think, playing Frankenstein with the body? And how do you recover? Say for instance, it's a river, and the river is full of pollutants. How do you recover the river and make it healthy again? And I guess that's the question from your expertise as a gut microbiome specialist. How do you take somebody that's been bombarded with the inflammation or a disease or some type of illness, and then you throw this thing in there, a cocktail of who knows what's in it or how it's going to affect an individual, and then how do you recover that person? Because I think that's really when most people find you. They're not finding you because they're like, damn, I want to eat right and I want to find good stuff, and I want to like make sure that I'm getting the polyphenols, and I want to make sure that I'm getting the prebiotics and the probiotics, and I'm getting enough fiber. They're like, no, my shit's broken. I don't feel good, and I don't feel right, and I got a bad attitude, and I'm not doing the things I like to do, and my body feels like it's cranky, and my joints hurt. Like, how do you take somebody when they're just like trashed by the medical system, and you get them back on their feet again? I mean, what do you do? How does that happen? Like, how do you recover somebody like that?
Yeah, that's a really, really important question. And I think the first part of that to understand, and the really important part is that you absolutely can recover, right?
Yeah.
So that, because people end up with feeling of hopelessness when
Yeah.
their system is so wrecked.
That's why I'm
right?
presenting it this way.
Yeah, so I think that's a really important question. So I'm glad, and thank you for asking that. So number one, yes, you can absolutely recover it, because ultimately what you have internally is an ecosystem. And like any other ecology, you can fix the ecology if you put the right pressures on it, right? And when it comes to the gut, even if you've had 15 rounds of antibiotics and you've devastated your microbiome, the good news is you can't kill off every single last cell of the beneficial bacteria, right? This is why cleaning products, if you look at your cleaning products under your sink, it says kills 99.99% of germs, right? Why does it not say kills 100% of germs? Because you can never truly sterilize microbes. There's always a 0.01% left there, right? So as a result of having that 0.01 or 0.1% left, is that if you start doing things to try to drive the growth of that beneficial bacteria, you can absolutely have them bounce back. It goes back to the pillars that we talked about, right? So the probiotic, prebiotic, polyphenols, fasting, and then you could throw in the fiber as well. Right. So starting somewhere around there within those 5 things, and then exercising, and then adequate sleep. So most people don't realize that resistance training actually builds your microbiome. So there are chemicals released by your muscles when you're doing contraction against a weight called myokines. These myokines leave your muscles, go to your gut, and actually shape your microbiome in a positive way. The myokines also reduce your stress and anxiety, right? Which also has damaging effects on the gut microbiome. So I would say all of these lifestyle practices, adding them in one at a time, adding some exercise and resistance training, adding a little bit of fiber, adding some polyphenols, adding a probiotic, adding a prebiotic, and knowing that the power of those things come from a cumulative effect of all of them being done consistently, right? It's not going to be any one of them that just moves a needle all of a sudden, right? It's the cumulative effect of all of those things that drives the ecosystem back to balance. And it can come back to balance from almost any point.
And then we create a happy, healthy person.
Absolutely.
And I'm gonna pass the microphone back over to Dr. Jason.
I appreciate that. This is fascinating, Kiran. Thank you for sharing all of this. I just want to jump in. I've at least two topics I'd like to chat on. I know we have like 10 minutes left in our discussion, or so, or so. Hopefully we'll have a few more minutes. I want to talk about SIBO, small intestinal bacterial overgrowth, and I have so many clients that I've worked with over. I mean, I've been doing this 2.5 decades. You and I connected early in my career as well, and guided me on a lot of my gut protocols. I appreciate that. Thank you. We've helped thousands of people together. Thank you. That said, I want to talk about SIBO, and I just don't like the diagnosis. To me, it's kind of like fibromyalgia or chronic fatigue. It's like you've got bacterial overgrowth, and then what do? Because I'm a gastroenterologist or a GP, I'm just going to give you rifaximin. Yeah. And it's like I mean that's the standard care, and it's the napalm of the gut. It literally is like just nuking everything in there. People will say, I feel better for fill in the blank months, 2 months, 3 months. And then all of a sudden my symptoms come back. And so what do? They get put on these rounds of rifaximin like all the time. And I see this and by the time we're testing their microbiome, there's nothing left. I mean, there's nothing good left in there. Overgrowth of commensal bacteria. And then sometimes pathogens are creeping in. I always kind of view in my simple head that the gut is like apartment buildings, and we want the apartment buildings filled up with happy healthy people, or happy healthy bacteria. And if we napalm everything, the ne'er-do-wells come in and they start squatting, and that's kind of the way I view it. Can you tell me about SIBO, like your experiences with this diagnosis? Is it real? Is it misguided? Am I onto something here? Or tell me about this run-of-the-mill treatment that everybody with SIBO gets put on.
Yeah, you're exactly right. So the question that is never being asked with SIBO is, why are those bacteria there and overgrowing? Right? It's just, they're there and overgrowing. Let's kill them, and hopefully that'll get rid of the problem. Well, it never does. Right? It's like everyone reverts after their course of rifaximin, and the question may be like, why didn't our ancestors deal with SIBO? Right? Why do you not see SIBO in hunter-gatherer tribes or Papua New Guinea tribes and so on? Why do you not see SIBO very much in rural people? You see it much more in urban people, right? So they're not connecting the dots there. And I think you're absolutely right in that, number one, there is a foundational issue that is being ignored that has allowed the overgrowth of microbes. And I have a few ideas on that I've lectured on, and I know clinicians who have used the strategies that I'm talking about have had great success. And number two, the killing protocol almost makes things worse over time, right? Makes you more susceptible because, like you said, you are essentially knocking down any sort of regulatory components of a neighborhood, right? And a policing component of a neighborhood, and allowing the most opportunistic microbes to continue to flourish, right? There may be temporary relief in a few weeks, but then it always reverts back to significant issues. So when I think about what prevents the wrong microbes from getting in the small bowel and overgrowing, there's a number of checkpoints and mechanisms, right? So number one is stomach acid, right? Adequate stomach acid is critically important so that all of these microbes that we're swallowing from our oral cavity aren't going into our small bowel in a viable state to set up shop, right? Our stomach acid is supposed to kill stuff that we are swallowing, especially from the oral cavity. Number two, the bile. So liver makes bile. Bile is a strong antimicrobial. Bile prevents microbes from growing in the small intestine too much, especially in the presence of food, when there's stuff for the microbes to ferment. Bile goes, nope, you can't ferment the food. This is not a chance for you to grow. This is the host needing to break this stuff down and absorb. All the fermentation happens in the large bowel. Mm-hmm. So if you're not a large bowel bacteria, no fermenting for you. And then on top of that, bile also triggers receptors in the small intestine called the FXR receptor that causes the lining of the small intestine to release antimicrobial compounds to maintain a low level of bacteria, right? So if we just look at those components, stomach acid, bile, and then the triggering of FXR receptors, those three things control overgrowth from happening in the gut. Then you look and go, okay, is there evidence that if those components aren't working, that you get SIBO? Well, absolutely. There's something called PPI-induced SIBO, right? Proton pump inhibitor-induced SIBO. Proton pump inhibitors shut down stomach acid. And as a result of it, you get SIBO because all of these microbes are going in a viable state. Then you look at people with liver dysfunction, right? Somewhere around 50, 60% of people with fatty liver or elevated liver enzymes also have SIBO and vice versa. So if the liver is compromised and bile acid is compromised, you'll get SIBO, right? And so it's all connected. And so then taking this approach of going, oh my God, they're overgrowing, let's kill them all. Oh my God, they came back again, let's kill them all again. And never looking at the root cause drivers becomes such a problem for people.
Go ahead, James.
Well, I think about it like our waterways and like a lake or a pond or a river or an ocean. And there's these algae blooms or plumes or whatever they call them that basically taint the water, and they're non-controllable, and they show up, and they're a byproduct of how we treat the ecology. And if we spray bad stuff on the soil, eventually it runs into the water. Eventually it has an adverse effect on the water. And now we're going to treat the water with something chemical to kill that. And then it comes back greater in the next year or the next year or the next year. And it seems like the same life cycle that you're talking about, but inside of a human body. And we are products of our environment. And I used to be told that you are what you eat. But now I'm picking up you are what you eat eats, and you are what you eat eats that has the microbes attached to it. So whatever it is, it's a downstream effect of like a 5-layer system. Like if what you eat has a bunch of toxic stuff on it, and then it passes through your body, it's going to eventually break down the gut lining. And eventually you're going to find some type of itis. And then eventually you're going to find out how to knock the itis down. And eventually over time, if you keep on the same behaviors, the itis reappears. And then you're wondering, why is the itis still here? And you're just basically explaining that to the people in like, scientific doctor talk with Dr. Jason here. I'm just trying to equate it to like the mom and pop that might be listening to our show. That's like, damn, our pond has algae in it and it shouldn't have it. Like, what do we do to get rid of it? Oh, they told us to spray this other stuff on there. Well, why do we have to spray the other stuff on there? Well, because what's running into our water and our ecology is tainted. And that's why we got a lot of sick people out there, because we're in a tainted environment and we're creatures of epigenetics. And if we have environmental factors on us, then eventually the people aren't going to be healthy. And then we need specialists like you guys to say, hey, we're going to unclog you and clean you up and send you back out there so you have a better quality of life and you might like yourself again.
I like that, James. Thanks for sharing that. I just want to say a statement, and then I have a question, and I hope that we can get to the answer. First of all, I used to say weed, seed, and feed, right? Get the bad stuff out, put the good stuff in, and then feed the good stuff. I had the either pleasure or curse of working with a very famous functional medicine doctor for a little bit of time, and she was very adamant about kill sequences or kill, and I just watched her patients degrade over time and get worse and worse. And I kept poking the bear on, I'm not sure this protocol is the way that we need to do this. Anyway, long story short, I played cleanup with a lot of those patients after I left that environment myself. I had to clean up my own environment. And since I just have abandoned kill protocols, kill sequences myself. And I really go into exactly that was the 5-layer approach. I mean, everything that you said is exactly what I do. And I see people's chronic conditions really turning around. So I used to say weed, seed, and feed. And I think the weeding part of it, getting rid of the bad stuff, I think a lot of those healthy bacteria, healthy probiotics, they kind of take care of the problem themselves.
Exactly.
And people ask me how that works. And I just, explain it in my way, which is, well, there's only so much food to go around. And if we keep putting the good bacteria in, they'll eat that food and the other stuff will die off. And then the good bacteria will kill the bad stuff. And it seems to work. So I'm more of a kind of a natural organic weeding, and then seeding and feeding a little bit more aggressively with your protocol, which I love. And I'm pretty sure I picked that up from you. To switch this into a question, I want to go back a little bit to, I don't know if it's neurology, and we were talking about neurology and mood and affect and all of that. And we talked a little bit about the relationship with the vagus nerve, but and we've also been talking about pain and
Mhm.
painkillers and things. And I'm not trying to be controversial. I'm really asking a question here. Recently, it came up Tylenol may be correlated to some ASD, autism spectrum disorder. And whether or not that's related, I can say that the research seems to show. So another reason not to take pain meds, but another way to approach it naturally. But the question is, low microbiome diversity seems to be directly related to the development and progression of ASD, at least in the literature that I've read. I'd love to hear, since it's kind of a hot topic right now, with a lot of things going on in the political world, what's your thoughts on ASD and the microbiome?
Yeah, I've lectured on this several times, and I've tried to keep up with the research around this, and really have tried to dig for more data on this. And from the way I see it, there's some very clear connections between the microbiome and the risk of developing ASD, and even predicting the severity of ASD. But that actually starts with the mom's microbiome, right, in utero. So there's some evidence, for example, on the full development of the baby's brain in utero, right? So we want the corpus callosum to develop properly. We want the myelin sheets, which are the insulation for all the nerves, to develop properly. We want the blood-brain barrier to develop properly. We want the right tight gap junctions to develop properly, all the synaptic regions. What's interesting about that is it seems like one of the stimuli for that, it may not be the only, but one of the stimuli for that is the binding of microbial polysaccharides on the placenta and in the baby's brain, right? So if you think about that and you go, what? So the development of the baby's brain, so arguably one of the most important things we want to happen to our human babies, which is the development of their brain, in part, we have outsourced it to bacteria. Right? So mom has these immune cells. We all have these immune cells called dendritic cells, right? That can reach across the lining of the gut and grab microbes and pull them in. And so they seem to be able to reach across and grab certain types of bacteria, like bifidobacteria, for example, that have a certain carbohydrate on their outer cell membrane. They grab that bifidobacteria, bring them all the way down to the placenta, digest the bacteria and the carbohydrate, and release those carbohydrates into the bloodstream, where they will bind receptors in the placenta and then get carried to the baby's brain, where they will induce the formation of the corpus callosum, the blood-brain barrier, and so on, right? So if there's an inadequacy in mom's microbiome and those types of bacteria aren't there enough, there is a chance the baby's brain doesn't get completely developed in utero. So then now the baby comes out already at risk of dysfunctions, and somewhere on that spectrum, right? Maybe completely functional, but yet some potential issues, all the way to non-functional. Now, on top of that, if the baby's microbiome, because the baby often gets the microbiome from mom largely, is getting an inadequate microbiome, then that will further imprint on the development of the child over the next few years, right? It's probably not a coincidence that it's really hard to see full symptoms of spectrum disorders until they're 2.5 to 3 years old, which is also when the adult-like microbiome gets established, right? So there may be just a pure coincidence, but it seems a little bit unlikely that it's coincidence given the potential role of the microbiome. There's also been a number of studies that show that ASD children, about 94% of them, have severe gut issues, right? This was a Stanford study that showed that. And then they also showed they have a very high prevalence of certain types of microbes like Clostridia bolte, tetani, and a few others as well. So there seems to be clear connection between that. Now, the other piece of this, I would say, is that when you look at conditions that we continue to see the prevalence increasing in our population, most of those conditions can be tied back to a dysfunction in the microbiome, right? So if you look at things like obesity and diabetes and depression and anxiety and allergies and asthma, all of those, there are clear mechanisms that tie them to a dysfunctional microbiome because our microbiome is getting worse over time, right? We're losing more and more diversity. We're passing on fewer organisms to our kids. Our hunter-gatherer ancestors from just a few hundred years ago had about 4 times the diversity that we currently do, right? And that diversity is declining from generation to generation. And so more and more issues are occurring. And as a result of that, when you look at all of these conditions associated with microbiome, the prevalence of those conditions continue to rise despite more medicine, more research, all of that stuff. Right. So I think it's a great question because it illustrates our vulnerabilities as a species, right? We hold ourselves in very high regard because we're so sophisticated and all that, but we are incredibly vulnerable to the functions of these invisible microbes in our system.
That's interesting. I'm going to pass it over to James here, but we just interviewed Daniel Tardy, and he said that, we have the invisible things in our environment are really the things that are causing a lot of the problems. And it's interesting that you're saying the same thing, which is very interesting. James, go ahead.
Well, I know that we're wrapping up soon, and Doctor, our colleague here, Kiran, has another call here in the next several minutes. But it sounds like that as our food gets weaker and the things that we feed ourselves, our culture gets weaker. And the more that we try to fix biological issues with pharmacological approaches, it doesn't really solve anything. It just makes us more dependent on really the pharmaceutical industrial complex, which we have Peter McCullough coming on next, and I'm sure we're going to take some deep dives on that with him. But as I've gotten to know you today, it's been really a lot of like real standard for if we just do a couple small things, we can improve people. But I did want you to give our audience a real life example of somebody that you've worked with and how you've helped them turn their life around. And then we'll put a wrap on today's episode. Yeah,
absolutely. I mean, there's a lot of examples I can think of, but one of my favorites is an employee of mine who was one of the earlier employees into Microbiome Labs. She was dealing with a number of things, and one of the reasons why she even came to know the brand is because she was desperately searching for solutions for trying to revamp her body after several rounds of treatments for SIBO and PCOS, polycystic ovarian syndrome, which is very related to the gut microbiome and also related to like insulin resistance and all that. So she's had loads of medications for that, loads of medications for SIBO, multiple rounds of antibiotics. She also, as a teenager, had multiple rounds of antibiotics for acne, right? So she had been on a year and a half worth of antibiotics for acne, and then the SIBO comes on, and then the PCOS. And all of those transitions are very, very clear how they're connected, right? So it was a case of almost like we are starting from scratch with her microbiome. But we did exactly what we've talked about in this episode, like going back to basics. How do we feed the microbes the right things? The good stuff is still in there. We just have to pull it out slowly over time. Adding back the polyphenols, adding back the prebiotics, the megaspore, adding a little bit of fasting, doing some resistance training, being prescriptive about getting outside, right? Prescribing her 3 times a week, minimum 30 to 40 minutes at a time in the not a natural environment, right? Getting outside and interacting with that environment. I always recommended to her, if you're going to go for a walk or a hike, make sure you touch the trees and the leaves and pick up stones and sticks and walk with it. Get the earth and the environment in your hands, right? And then sit down and eat something. Eat an apple, eat a banana, something that you're touching, and then you're putting into your system. So just those basic steps, one by one, cumulatively over time, completely revamped all of those conditions for her, right? She's no longer dealing with SIBO. She's no longer dealing with PCOS. She's no longer dealing with the anxiety that she had. And then she's no skin issues as well. and she became, a long-term amazing employee of the company because she was a living example of everything that we talked about.
Wow.
So it's fascinating and amazing to see that.
Well, that's what I call eating your own cooking.
Yeah.
And she's a product of her own environment at that point, and it sounds like it's really cleared up her life, and a great example to share, because there's so much more that I'm sure Dr. Jason and I wanted to take a journey on with you today. We did some dives on some incredible topics, but is there anything in closing that we didn't ask you that you want to share with our audience today?
Just I'll make one additional point and then just a statement. So one additional point is also to start thinking about your skin microbiome. This has been an area of passion of mine for the last few years, looking at this concept of leaky skin and how dysfunction in the skin barrier is driving chronic conditions. There's one of the longest longevity studies, which is still going on. It's a 65-year-long study called the Baltimore Study of Longitudinal. The Baltimore Longitudinal Study of Aging, where they've basically figured out that disruption in the skin, and then driven in part by the skin microbiome changes, and the leakiness of the skin becomes an independent risk factor for chronic disease. So it's a really, really interesting topic, and I'd welcome an opportunity to come back on and talk about it. But the statement in addition to that is that it's never too late to make a change, because this is an ecosystem that you're dealing with, right? And as any kind of ecology, any farmer knows, any gardener knows, anyone that knows anything about ecosystems knows that with the right things, the right additions, the right restrictions and so on, you can make a change in the ecology. You can always change. I don't care if you're 90 years old, you can absolutely make a change in your ecosystem for better health. So you have, and the thing is, you have a lot more power in your own hands than you think, right? Your doctors, if you have a good functional doctor, will guide you. But a lot of it is the decisions you make every single day, the small decisions you make, and the culmination of those decisions.
Well, thank you for sharing with that. I think it's really important. We will get you back on for a further episode of the Get Better Faster podcast. Dr. Jason, do you have any closing remarks for Kiran today?
I just want to say I love this interview. It's been great. Thank you, Kiran, for your time. And then also I was going to say, let's have you back on, because I want to talk about the skin microbiome. I want to talk about the vaginal microbiome. We talked about SIBO and rifaximin, but bacterial vaginosis is rampant. And again, it's the same kind of treatment over and over again. And it keeps coming back. So I want to talk about that, which also leads me into another topic that we'll chat about next time, which is testing, stool testing, vaginal microbiome testing, et cetera. I know that you have a whole expertise in that area as well. So we didn't get to touch on it today. So I can't wait for our next interview, so thank you again for your time today.
It's my pleasure.
Well, I'll go ahead and put a wrap on today's show and say thanks, Kiran. It's been absolutely mind-blowing. The small bit that we did share with our audience today, I think, is going to help some people tremendously. The real life example that you used at the end, I'm sure is going to give a lot of our listeners some clarity. But for our listeners out there that are still sitting there and realizing that their gut health might be the missing piece that they're searching for, Kiran and his team at Microbiome Labs have developed a clinically proven spore-based probiotic system that actually survive your stomach acid and get to work where they're needed most. This isn't just another supplement that ends up down the drain. This is science-backed transformation that healthcare professionals rely on daily, like Dr. Jason Bradley. And although through our partnership, you can access these protocols that really change lives. Go to sivcare.com to learn more, and we'll have our exclusive affiliate link in the show notes so you can take advantage of the special offer that Kiran has with his team. And remember, guys, nobody's coming to save you, but solutions like this can prove that you can save yourself. Kiran, once again, thank you so much for sharing your expertise and your passion and your knowledge today. And to all of you, our Get Better Faster Nation, thank you for listening and your continued support. You know the best way to show your support is share this episode with somebody who needs to hear this message, especially anyone dealing with gut issues, autoimmune problems, and chronic health challenges, as we just discussed, skin conditions. And and don't forget to subscribe to our show so you can hear Dr. Jason and I interview subject matter experts regularly and never miss another episode. And also, I'm sure you guys want to get all the behind the scenes hijinks we've got coming your way with our esteemed guests. We've got more incredible ones lined up for you to keep growing and blowing your mind with real solutions for reclaiming your health, your happiness, and your life. Until next time, keep questioning everything and keep getting better faster. Thank you, gentlemen.
Thank you.
Thanks, James. Thanks, Kiran.
All right.
See you next time.
Bye for now.
Bye-bye.